Good day, folks. It's DIY Guy 123 here. Today I'm going to take you through everything you need to know to take your basement floor from this, which is just a regular vinyl glued on tile, to the concrete floor that's not insulated below. It's terribly cold even in the summer. To this, you got a finished floor that's warm. You're not going to have condensation occur on it in humid weather, and it looks great and it's very durable. So first things first, I'm going to talk to you about what tools you need. You don't need 100 different types of tools here. Very basic stuff that any do-it-yourselfer is going to have. Extension cord, circular saw. This saw, I think it might be called a coping saw. I'm not sure, but anyway, they work great for cutting the trim. A miter saw. You don't need one as big as that, but that's what I happen to have. Pry bar for getting the trim off. You need a hammer drill for drilling out the concrete floor and driving in these nails. You don't need a Porter cable as large as that, but again, that's what I happen to have. You definitely do not need a big drill for this because your drill bit is only going to be a small like 5/32 bit, something like that. So anyway, a small hammer drill is fine. A hammer, and you want a bigger hammer than just a regular cheapo hammer. You want one that's got some weight to it to drive those concrete nails in. About 40,000 pencils and tape measures because I keep leaving them around. Acoustic sealant. This is the larger size tube in the larger size gun. Not necessary, but it is cheaper to buy it in the larger size tubes. A few different assortments of knives that you'll want to have a few different kinds for various types of cutting. A square for cutting the cutting the flooring, and safety protection gloves, safety goggles, as my kids call them, and hearing protection. I do have a table saw, and there's a very specific need for a table saw. I could get away without it if I wanted to, but you're going to see when I talk about the foam insulation why I use a table saw. You can get by with a regular circular saw. So the first thing you need to address is any standing water in your basement. You definitely do not want any intrusion of surface water coming through a foundation wall or water bubbling up from the ground like the water table. If you have that problem, then this flooring project is not your first step. You have to resolve that. Fix the cracks, fix the drainage away from your house at the surface level, do new drain tile, whatever it is, but you cannot do this flooring project if there's any risk of water coming into the basement other than humidity from, evaporating from the concrete pad. So going in with that assumption, and that's the case in this basement, no surface water, but there is humidity trouble here in the summer because the floor is so cold in the basement because it's below grade that when there's warm in the back of the basement, this side it's below grade, on this side it's a walkout, and when the humid air comes in the summer, hot humid days, it actually condenses on the floor, and it's a significant problem. Plus, all year round, this floor is just terribly cold. So what I wanted to do was look at stopping any humidity problems from moisture coming up, deal with an insulation, deal with making the floor rigid, and then putting a finished surface on the top of it. So the first thing you need to do is take all the trim off the whole place. I've seen people leave the trim on, build the flooring up, and then put quarter round around it. I don't like that. That's personal preference. I don't like that. So I take the trim off. I'll be using a pry bar and a hammer to get that trim off. And once the trim is off, you vacuum the whole area. If there's any mold on the floor or anything like that, clean it with bleach to kill it. And then you're going to be laying out polyethylene plastic vapor barrier. So lay it out through the whole surface. Now, I used acoustic sealant to seal it to the floor. There may be better products for that. I know acoustic sealant is designed to minimize air passage through two surfaces, but it certainly works well here as well. And so I do the perimeter with acoustic sealant and then push the plastic down. If there's a spot where I've been, not doing this whole room or not doing the whole basement at one day, I've been doing it over multiple days. And so to prevent people stepping on it, I actually use tuck tape for any of the, so this is vapor barrier from when I did that surface, and then of course nothing on this surface yet. So tuck tape will work, but acoustic sealant is a superior product over the long term. So after you get the polyethylene laid out and taped down, the next step is to lay down some insulation. Now I've seen people with in hardware stores with 2 foot by 2 foot tiles that have an OSB product on top of them. It's tongue and groove, which is great. And then on the bottom, there's like an eggshell type plastic membrane on the bottom to allow any water that got on top of the concrete pad and below the flooring to pass through. Also, you have a chance if water got there, it may evaporate someday or travel to a drain. So that's why that's there. Also, that egg carton shape is to perform a thermal break between the cold concrete and the warmer OSB. So that's all great. The other type of product that I've seen is the same kind of thing, 2 foot by 2 foot tiles, but on the bottom of it, it's got foam glued to it. Now the foam has little scores every 4 inches or every 6 inches. There's a grid of scores on the bottom for the same purpose, air movement, moisture movement, that sort of thing. None of those solutions had enough R value for what I wanted in this basement. This is going to be an R7 and a bit. And most of those tiles that I mentioned have like an R1 to an R3, I think. So I wanted twice the R value. And the only way to do that is to have thicker foam insulation. And so what I've gone with here is an 1.5 inch foam. Now there's a whole debate whether XPS or EPS or any other types of foam are the right things for basements. Do all your own research. That's a whole video in itself to talk about the different types of insulations and the pros and cons. Some of them are resistant to moisture more so than others. Some of them are more dense, so they resist crushing. Others have a better insulating R value per inch than their competitors. The biggest thing that I want to talk about today is compressible strength. So you definitely want to have the insulation that is designed to be in floors, either under a concrete slab or over a slab in this case. So this type of insulation is rated for 16 psi. So that means if I had a 16-pound weight and it had a 1 inch by 1 inch surface area and I put it there, it's on the verge of permanently denting this styrofoam. Doesn't sound like a lot, 16 pounds, but when you look at if there's a 12 by 12 area, so a 1 foot area, that's 144 square inches. So 144 times 16, whatever that is, how many thousand pounds, a couple thousand pounds or something, in a 1 foot area, that's what's required in order to make this crush. So 16 psi, I called the manufacturer and they said this is designed to go underneath the concrete slab. So it's more than sufficient for going above the concrete slab. Now, I'll show you right now. I can permanently dent that with my thumb and that'll never recover, that one little spot. But if I had had OSB on top of that, even kneeling like my knees, that probably put a dent in it. But now if I do the same thing, if I spread the load out with some OSB like that, that's not going to dent or make any permanent damage. So the key thing is stay off of this as much as you can until you get the OSB on it, and then it's hard, or stable and strong. So remember I told you the 2 foot by 2 foot tiles have a grid cut in the bottom of them for air passage? Well, I made my own grid. There's no real right or wrong way to do this. I wouldn't want to cut too many ridges in because then you increase the risk of having the remaining protruding surfaces getting crushed if there's just not enough area to support the weight. But really, I don't think it's a big deal. I definitely did not feel I needed as many ridges or grooves cut in as the factory 2x2 tiles. But I wanted some, so I've cut them using a dado blade on a table saw. And that's not something that everyone would have. I'll show it to you here. What it is it's multiple saw blades stacked together. And any furniture maker or whatever would know all about this, but there's a blade, there's another blade in the center, and then there's a blade there, and you can stack blades to make that wider, called a dado blade. So I use that to cut my ridges in the foam. It takes not a real long time to do 10 sheets like that. It's probably 10 minutes or so, and it's nice to have a helper because they're very flexible, so it's good to have someone hold the other end that's flapping when you're cutting the far end. But in doing this, I was able to avoid an extra layer, and that extra layer I'm referring to as dimple board. There are various products out there. There's a brown product that's very common. I don't remember who makes it, but here's an example product. Now this product is a great product. I've used on the exterior foundations to protect against water intrusion. And what it does, you put it dimpled side down, It's extremely strong. You won't crush those dimples, and water and air can pass underneath those dimples. Great idea. Problem is, for this 800 square foot basement, I was going to be about 700 bucks, maybe 600 bucks in purchasing this stuff. Plus, it was raising the height of my floor by 3/8, and I really, ceiling height is very important in a basement. And so by cutting these grooves in, I can avoid the dimple board completely, saving the money and saving the height loss, and I get the extra R value. So I'm super thrilled about this approach. So this styrofoam is tongue and groove, just like the OSB. It goes together really easy. You can cut it with a knife and bend it and it'll snap. And you basically want to cover the whole floor with this foam, and the next step after that would be the OSB. Now, I actually took this a bit further. I oriented all of these panels. Of course, it's upside down now because these ridges go against the concrete floor. I oriented all of these ridges so that all the styrofoam sheets line up to each other, so there's a common track. So along this whole hallway, it's a 40-foot hallway here, along the whole hallway, that passage is common all the way this way, and this grid in the opposite direction is common all the way this way. And I plan to take this device here, which I think is called a it says humidity vent. I've heard them called a humidistat. Anyway, they take air from the bottom inside and throw it outside. So of course, dense air is at the bottom, which is more humid air at the floor level at the bottom, and it takes it and throws it outside. That's all it does. It doesn't condition anything. It's just a fan. So I'm going to take that and move it to the humid side of the basement, and in the bottom of it where there's the intake, I'm going to plumb it to various piping that goes through various aspects of the various rooms, and then I'll take a hole saw and drill a hole into the flooring in an inconspicuous area, maybe a corner or something, and then run a pipe down to tap into those channels underneath this foam. Now, is this overkill? Yes, it is, and I'm not recommending anybody else do it. I'm just curious about seeing how well it will work, if it will actually, I don't know, keep the basement smelling more fresh. And okay, so another important thing is when you add foam and OSB and flooring, your doors that used to close aren't going to close anymore because the floor has been raised. So it's very easy to cut a door down. It's easier if you have a table saw, but you can do it with a skill saw. So obviously you're not changing the hinges, you're not changing the top of the door frame or the width. You're not going to mess around with any of that. You do not cut off the top and reset the hinges or the door handle. You only cut from the bottom. Well, how far do you cut from the bottom? So that's a key question. And what I like for a bedroom door, you want it to shut as tightly as possible, as close to the floor as possible, to retain heat, to keep noise from coming in or going out. And so that's why, now it might be different if you had a forced air heating system, but anyway, if you don't, then I want this to be as tight as possible. So if you can see here, I can fit my hand into there. The door was originally, in my opinion, too high off of the floor. So I want to take that into account, and when I'm raising the floor by this, plus this, plus this, when I'm raising the floor by that, I'm not going to cut whatever that height is. I'm not going to cut that off of the door, because then the door will have that much gap again above my new floor. So instead what I'm going to do, I'm going to mark this, and then you have to ask yourself, well, how much of a gap do you want between the new floor and the door? I would say maybe 1/4 of an inch, no more. Now, if your floor is on level, if your door isn't plumb, when you open your door, it's going to drag on the new flooring, and so you may have to trim it a bit tighter. But for now, so I've got the foam, the OSB, and 2 pieces of flooring, and when I cut that off at that height, that's going to leave a gap this big above the new flooring and the old door. So that's exactly what I want to do. You need to run around and do that to all your doors. Now, closets are a bit different. Closets, you do want air circulation. So, there's a good inch there. I don't know what the recommended value is, but you certainly want, you don't want a tight gap. If somebody puts a wet, sweaty gym bag in there or a bath towel that's wet or something, you want to have good airflow through a closet. So I don't know if I quite need that much. There are gaps around the doors all the way around, and this is a vented set of doors, so I'm not overly concerned about it. So since they're vented, I'm not going to cut them. I'm not going to leave this much of a gap. I'm going to make the gap shorter. So, but when I look at this, you've got to leave room for that bracket right there. So you can't, unlike the entry door, the door could be, you know, 1/4 inch off the flooring, and then it's going to be clear all the way. In this case, it's got to be higher than even that. When you cut the door down, you've got to take into account these are spring-loaded doors. That's a spring-loaded feature there. So I'd encourage you to take some time and understand how those doors work. To get them in and out, it's very simple. All you do is you take 2 hands and grip the door, lift it up, and then swing the bottom out. And then the door will come out, and the installation is reverse of removal. The only tricky part is when you go to put the top in first, you make sure that the rollers are in the track, or sometimes there are different types of sliders in there. You got a pin that fits into a slider. Just make sure that that's aligned, and then you slide the door back in. When you want to adjust, and this one's not adjusted well, the gap between the top of the door and the bottom of the door, there's no gap there. I think it moved because I fiddled with it at the top. You just basically pick this up and move it in or out, and it'll drop down in the gear, in these not the gear, but in these this tooth slot here. And then if the door needs to be raised or lowered, there's a threaded rod there that you unscrew or screw in to raise or lower the door. So take all into account. Trim your closet doors down. Trim your entryway doors down. And I'm going to show you how to do that on a table saw in a minute. But the biggest thing is you mark them. The next thing I'll show you is even after your baseboard trim is off, your door trim is going to remain, and you're not going to be taking that off because there's just no need to take it off. So the question is, well, okay, how do I deal with that? And I want to get my flooring to fit underneath this. So again, you take your foam OSB piece of flooring on top, and you use this kind of a saw, again, coping saw maybe, not sure if that's really it's called a multi-crafter, whatever that means. But anyway, basically this little blade vibrates back and forth. You set your blade on here, and you cut that trim out. So you get the idea. Now, if you're really finicky and picky about it, you would take a piece of flooring, you'd shave it down the thickness of that blade so that after you do this cutting, your new flooring will fit in there, and there will be no gap between this piece and this piece. I'm not that picky about it, and if you do it that way, it's going to complicate your install. It's very tight fitting. So I just take a full thickness piece of flooring, use that saw to cut the trim off, and if there's a gap, this extra gap the size of that blade, I don't care. So look, you're going to do that on the door trim, on the door jamb, I guess. But something to note, you got to remove these closet brackets here. They hold the base of the closet, that little threaded rod, and you know, they're already installed in the right place originally, so don't just unscrew this and take it out. Mark with a pencil just above where that bracket was, so that when you go to reinstall it, you don't have to measure anything. There's no guesswork. You just put it right back in the center where it was before. So you'll see why that's important when we go to reinstall the closet. Then you've gone through and your whole trim has been either removed or cut up to